Good morning, guys. So today I'm going to look at the types of random variables, and that is when you look at the lecture notes, that was definition 1.17. So first of all, we have two main types of random variable, and the first one being discrete random variable distribution, right? So the first one being discrete distribution, and the second one being continuous distribution. The second one is also continuous distribution. So when we look at the discrete case, in the case of the first one, that is the discrete distribution. So you can say that a random variable x, let's say a random variable x with a PDF or with a distribution with the distribution f of x is called discrete. It's called discrete. If there exists a finite set that is I equals to, let's say, T1 up to Tk, it's okay. So basically what I'm trying to say is that a random variable is always said to be discrete when the outcome it takes what the countable numbers, that is, it can be 0, 1, 2, 3, 4, 5, and the rest. So let's say if I give you a distribution function and I say find the probability that x is equals to 0, x is equals to 1, x is equals to 2, then what has to come into mind is that I'm dealing with what? A discrete distribution. It's okay. So what comes to mind is I'm dealing with a discrete distribution. It's okay. And always probabilities between 0 and 1, right? Always probabilities between 0 and 1. Yeah. And when I ask you to find the cumulative distribution, that is f of x of t, is equals to summation of, you sum up the probabilities of the x, in the case of discrete, right? Where the x belongs to negative infinity up to t, and they are all countable numbers. With this t, yeah, great. And the second type of distribution is what we call the continuous, right? So the continuous distribution, the continuous distribution. So in that case, so you can also say a random variable x is said to be continuous. Is said to be continuous. Is said to be continuous if there exists an integrable function, f of x, which maps to 0 and infinity, is okay. So what this also means that anytime that you are given a function, and in that function you always have something like this integral, that maybe I say find the probability that x is between less than or equals to 2, x less than or equals to 5. When you have something like this, because you are always going to integrate, you call that one continuous. So in this case, if I say find the probability that x is between 2, 2 is less than x, and x is less than 5, it can be 2.1, 2.2, 3, and the rest, you get it. So in this case, you can only integrate to find out your probability. So when you have any distribution like this, we call it continuous distribution function. Is okay. Now, so let's look at the basic examples of discrete distribution. So when we come to discrete distribution, let's say we have the Bernoulli distribution. Bernoulli distribution. Now with the Bernoulli distribution, what it means is that always you have two possible outcomes. Let's say you perform an experiment, like you perform an experiment once, Bernoulli distribution. So Bernoulli distribution, an experiment can be classified as Bernoulli when it is performed only once. The key thing is that it is performed only once, and it has only two possible outcomes. It's okay. So in that case, we have I. It has two possible outcomes, either 0 or 1, right? For instance, if you throw a die and you say that, okay, and you're interested in the head, then you can say that, okay, if I throw a die and the head shows up, I assign a value of 1. And if the head does not show up, I assign a value of 2. That means you have only two possible outcomes. It's either you have 0 or 1. Either the head shows up or it doesn't show up, right? Okay. And that experiment is being performed not only once. So in that case, the probability mass distribution, P of X, we say is equals to P for X equals 1, and then 1 minus P for X equals to 0. So what it means is that, let's say if I throw a die, if I throw a coin and I'm interested in the head, then if I throw a coin and it shows up X equals to, it shows up as 1, I'm going to assign a value of what? 1, and I can have that one with the probability of what? P. Because always coin is fair, we say probability of half, right? The experiment is always fair. And if it shows up at as tail, then I can also assign a value of what? 0. Then the probability that it shows up as a tail becomes what? 1 minus P. Is okay. So mostly people say that the probability of success, that is what you are interested. If you're interested in the head, then what is the likelihood that when you perform the experiment, you have head to show up? If head shows up, you assign a value of what? 1. And if head doesn't show up, you assign a value of what? 0. Is okay. And the probability of having the head, which is what you are interested in, is P. And the probability of not having the head is 1 minus the P. Is okay. So this is what we call the Bernoulli distribution. So the key thing that you're supposed to note is, 1, when it comes to the Bernoulli distribution, the experiment is performed only once. Let's say I throw a die once. And with this experiment, I can only have two possible outcomes, either head or tail, or 0 or 1. It's okay. So when you have any distribution that follows this pattern, we call it Bernoulli distribution. And this is one example of a discrete distribution. And another one that we also know is the second one. Let me call this A. The second one is binomial distribution. Binomial distribution. It's okay. Yeah. Now the same thing with binomial distribution. Binomial distribution too, you have only two possible outcomes. Let's say you throw a die, it's either head or a tail that you're interested in. But in this case, the experiment is performed more than once. It is performed repeatedly. Let's say you throw a die 5 times. But in the case of Bernoulli, the experiment is performed only once. Is okay. But the binomial also have the same property of Bernoulli, but just that it is performed more than once. So let's say you throw a die. The possible outcomes are either head or a tail. Sorry, you throw a coin. Your possible outcomes are either head or a tail. But this experiment is being performed more than one time. It can be 3 times, 5 times, 6 times. It's okay. So when you throw a die repeatedly, like six times, and you're interested in only the head showing up or the tail showing up, it's okay. So this also has the mass function as P of X is equals to N combination X, probability of X, and then 1 minus P, N minus X for all X belonging to countable numbers, right? It's okay. So this is what we call binomial distribution. After this, I'm going to look at some few examples for you to understand. So don't worry. So another discrete distribution that we can also look at is the Poisson distribution. The Poisson distribution. So the Poisson distribution also takes on a natural numbers. That is, I takes on natural numbers. That is, it can start from 0, 1, 2, 3, 4, 5, 6, right? So that also has a mass function of probability of X. Let's say is equals to K is equals to e raised to the power negative lambda, lambda raised to the power k, k factorial, and for k belonging to natural numbers. Is okay? Great. So that is a Poisson also distribution, right? And then in the case of, so let's say, great. Let me look at, no, I'm going to look at it in the future, but let me also talk about this. Sometimes you may be asked to find the expectation. Okay, I will look at that in the future, don't worry. So let's look at the next one is the continuous distribution. The continuous distribution. The continuous distribution. With the continuous distribution, we have first A. We have the uniform distribution. And then let's say the uniform distribution on interval A, B, right? Always when you see this expression, this brackets here, it means A and B inclusive, right? So when you have this and you are asked to find the distribution, the mass function becomes, in this case, when it's continuous, it's called density function. So f of x is equals to 1 over upper limit, which is b, minus lower limit, right? For x belonging to a and then b. And this is the same as what a is less than x and then less than or equals to b, right? So something, this for instance means you would have to integrate. It's okay. And we said anytime that you have integral function in it is what? It is called continuous. So this is when the x falls between a and b and 0 elsewhere. Right? So this is what we call the continuous distribution. I'm going to look at examples in the future, right? And the second one that we know is also exponential distribution. Exponential is also a continuous type of distribution. Exponential distribution. Great. Now the exponential distribution too also has the function p of f of x is equals to the same thing, lambda e raised to the power negative lambda x, right? For all x, greater than or equals to 0, right? And then 0 elsewhere. When you have this type of the density function, we also call it what? Exponential distribution. And we have different types. We have several types of discrete and then normal discrete and then continuous distribution. But I'm going to limit myself to what was taught in the class. And the third type of continuous distribution then becomes the normal distribution. And the normal distribution is very, very important in statistics. Normal distribution, right? So the normal distribution also takes this f of x equals to 1 over 2 pi variance square e raised by negative half x minus mu over standard deviation squared, where this is the same as the volatility or the standard deviation, and this is the same as the expectation of the mu. Is okay. And when you are asked to find the distribution, the same as probability of x less than or equal to t, which is the same as f of x. Let me make it capital F of x, right? With t. Okay, that means you integrate from negative infinity up to t, f of x dx. Is okay. Great. So this is in this video we've looked at what the discrete and then continuous distribution, and we said when it comes to the discrete distribution takes up countable numbers 0, 1, 2, 3, 4, 5, and the rest. And we talked about types of discrete distribution. We did mention of the Bernoulli distribution. We talked of the binomial distribution, and we talked of the Poisson distribution, right? And when it comes to the continuous distribution, we said it always takes what of integral functions. And we also talked about the uniform distribution. We talked about exponential, no, right? Exponential distribution, right? And then we've looked at the normal distribution. Okay. So in my next video, I'm just going to look at example from each of the distribution, and maybe I'll look at the expectation too. Thank you.